Hello friends, I welcome you in lecture number 13 on exponential distribution. We will discuss one more example on exponential distribution in this lecture also. We will discuss one example on mean and variance of exponential distribution also. For that we recall that suppose our random variable capital X follows exponential distribution with rate parameter lambda, then mean of x is reciprocal of lambda and variance of x is 1 divided by lambda square. That means standard deviation is 1 divided by lambda, and here lambda is average number of events per unit of time, and that is always positive real number. Therefore this makes sense, we can divide by lambda. So first we try to answer this question, or we try to understand the solution of this problem, and then we will see example on finding mean and variance or standard deviation of exponential distribution. In this example, it is given that customers arrive at a help desk at a rate of 6 per hour. That means average number of customers arriving at a help desk in 1 hour is 6. It is given that in 1 hour time average number of customer arrivals are 6. Using this information we have to find the probability that the next customer arrives in less than 5 minutes. So first we define our random variable capital X. Here we are talking about the time until the customer arrives. So we consider capital X as the time until arrival of customer, or time until the customer arrives. And here we are asked to calculate this probability in minutes. So here our unit is minutes. This is our capital X, the time until the arrival of customer in minutes. And to apply exponential distribution, we will require parameter of exponential distribution denoted by lambda, and we recall that lambda is average number of events per unit time. So here we are interested in the arrival of customers. Therefore lambda is average number of customers arriving per unit of time. Here unit of time is minute, so we have to consider average number of customers arriving per minute, or average number of customers arriving in 1 minute, that we require to apply exponential distribution. But here we are given that in 1 hour average number of customer arrivals are 6. So using this information we can obtain the average number of customer arrivals in 1 minute. So for that we can do this type of process. Here I write minutes and here I write number of customers or customer arrivals. We are given that in 1 hour average number of customers arriving are 6, and we are interested in 1 minute. So in 60 minutes there are 6 customer arrivals. Therefore in 1 minute we have 6 into 1 divided by 60, that is 1 divided by 10, and that is equal to 0.1. Therefore lambda, which is average number of customer arrivals per minute, is 0.1. And once we find out lambda, we can calculate the probabilities either using probability density function or cumulative distribution function of exponential random variable. So we are using CDF, that is cumulative distribution function. We have ready-made formula for the CDF of exponential distribution, which is capital F of x equal to 1 minus e raised to minus lambda x, and here our lambda is 0.1, so I put lambda equal to 0.1 here, and I obtain the formula for CDF. Now here they have asked to calculate the probability that the next customer arrives in less than 5 minutes. That is equivalent to the fact that the time until the arrival of next customer is less than 5 minutes. So now we write that we are asked to calculate the probability that a customer arrives in less than 5 minutes. This is equivalent to the probability of time until customer arrives, this time is less than 5 minutes. These two statements are equivalent. Customer arrives in less than 5 minutes, that we can rewrite in another way as time until the customer arrives is less than 5 minutes, and time until the arrival of customer is considered as random variable x. So we have to calculate the probability that capital X is less than 5, and we know that if x is continuous random variable, then whether we are writing x less than 5 or x less than or equal to 5, both are equivalent, and this is by the definition of CDF, this is equal to f of 5. Definition of CDF is f of x equal to probability that capital X is at most x. So here we are taking x equal to 5, so this is equal to f of 5, and we have fx here, so here we put x equal to 5, and we will obtain 1 minus e raised to minus 0.1 into 5. So 1 minus e raised to minus 0.1 into 5, and this is 1 minus e raised to minus 0.5, and using scientific calculator I find this as 0.3935 up to 4 decimal places. So this is easy problem. All we have to remember is that whenever we are dealing with the time until some specific event occurs, we will use exponential distribution, and for that we will require the value of parameter lambda in particular units, and that units will be decided from the question itself. Here we are asked to calculate the probability that next customer arrives in the unit of minutes. Therefore, we will require rate parameter per minute. If we are asked to calculate the probability in hours, then rate parameter will be average number of customers arriving per hour. Similarly, per second also. So remember that whenever we are dealing with the time until some event occurs, or time between successive events, then we have this capital X following exponential distribution, and parameter is lambda, and always remember that lambda is average number of events per unit of time. So if this is in hours, then lambda is required per hour. If this is in minutes, then lambda is required per minute. If this is in seconds, then we require lambda per second. And we are using CDF, that fx equal to 1 minus e raised to minus lambda x. If we wish, we can use PDF also. Suppose I am not going to use CDF, then I can write down the formula of PDF. It is lambda times e raised to minus lambda x. Lambda is 0.1, so we have 0.1 and into e raised to minus 0.1 into x, and if I am interested in this probability using PDF, then this I will integrate from -infinity to 5. Here we will put fx, and after integration we will get the same value which we have obtained using CDF. So that is your choice. You can either use CDF or PDF to calculate the probabilities related to exponential distribution. And this is another example which is very easy. They have asked to write down the mean and standard deviation. It is given that lifetime of a battery follows an exponential distribution with rate parameter lambda equal to 0.02, and you have to calculate the mean lifetime and the standard deviation. So here first we can write down that capital X is nothing but the lifetime of a battery. This is the random variable here, and it is given that the lifetime of a battery follows an exponential distribution. That means this capital X is an exponential random variable and rate parameter is given as 0.02, and using this we have to calculate the mean lifetime. Lifetime is denoted by capital X. So mean lifetime means expected value of X or mean of X, and we have to calculate standard deviation. Now we know that if we have exponential random variable with parameter lambda, then mean of X or expected value of X is given by reciprocal of lambda. So this is 1 divided by 0.0, and this turns out to be 50. And this is for first part, that is mean lifetime. Therefore the mean lifetime equal to 50. Here they have not specified the units, so this lifetime can be hours or any other unit, but we are not worried about the units here. Okay, we just have to write down the mean and standard deviation. Similarly, we know that variance of exponential distribution is given by 1 divided by lambda square, and therefore standard deviation is equal to 1 by lambda, and that is equal to mean, and that we have calculated. So for exponential distribution, mean and standard deviation are equal. So here we have to just answer these two parts, that mean lifetime, that is expected value of X, which is 1 by lambda, and that is equal to 50, and the standard deviation is equal to mean, and that is also 50. So in this way we can solve this type of problems related to exponential distribution easily. All you have to remember is that this capital X, that is how exponential distribution is defined, or how exponential random variable is defined, and what is the parameter of exponential distribution. And if you remember this, either CDF or PDF, you can calculate probabilities related to exponential distribution easily. So this is all about this session. I hope you like it. Thanks for watching.